Hey guys, we're talking about confidence intervals. So, we're doing the same thing we were doing yesterday in yesterday's video. We need to look at 10% rule, large count condition, critical values, but the bottom line and the purpose for that is because here we're going to be constructing and interpreting the confidence interval. And yeah, we are going to take a little time also to do it with technology, because why not? And also, we're going to dabble in determining the sample size. So, go to page 6 of your notes and read over it. So pause right now. Okay, now you should have already highlighted this, but what is this all about? We're talking about, are we satisfied or dissatisfied in the way things are going in the United States? So we're talking about when the Gallup poll occurred in 2010. Here we have 256 said they were satisfied, and here remaining 769, okay, said they were not. We've got a 90% confidence interval that we're looking for. Okay, so let's make a note of, first of all, our sample size n, our p hat. So our n is going to equal 1025. Our p hat is going to be the 256 over 256 plus the 769. Because please note, what did they say? They said the remaining 769, so we have to add that together. Now, we're about to start the 4-step process. Oh, I should have mentioned what n was. N, as we said, is the 256 plus the 769, which gives us the 1025. So now, let's start our 4-step process for this confidence interval. So step 1, I'm making a statement. I know I'm doing a 1 proportion Z interval, and I have a 90% confidence interval or a 90% level C, a 90% confidence interval that I'm constructing, where we're trying to determine the true mean population of all U.S. adults who are satisfied with the way things are going in the U.S. in January 2010. And if your thoughts are that timing doesn't make a difference, let's face it. All you've got to do is have the State of the Union addressed and your ideology changes. Or all you got to have is, unfortunately, a terrorist attack and your ideology changes. So the timing does matter on this. Now, step 2. Step 2 are our CNA, conditions and assumptions. And I'm going to apply something that I have mentioned. This is the first time I'm mentioning this. We're going to look at sin. Okay? Sin being the S part is our adult random sample, the SRS. The I is actually for independence, even though it's not been introduced, but it will be in the future, so why not use it now? So of all adults in the U.S., yes, that's going to be greater than 10 times the 769. And the N part of sin is normality. Here we use the N times P naught, the large count condition, seeing if it's greater than or equal to 10, so therefore approximately normal. So when I'm looking at sin, I'm looking at SRS, independence, and normality. And that we're going to be using consistently throughout for the rest of the book, because we can utilize that for hypothesis testing and confidence intervals. So we've done step 1, we've done step 2. Now let's jump to step 3, which we're doing the math. Well, at least the calculator is. Okay, step 3. Here is the formula for our confidence interval. Please recognize that I've got hats in there. Why? Because confidence intervals are about the samples, and the samples. So I take it and I plug it in, and I get then here's the math. And my confidence intervals between is going to be 0.23 and 0.27. which leads me to now, what is the point of all this? Conclusion. We are 90% confident that the interval of 0.23 to 0.27 captures the true proportion of all U.S. adults that were satisfied with the way the things are going in the U.S. in January 2010. Now, what about, your thoughts should be, okay, man, this is the first time we've actually done some math. Nah, I'm going to calculate to do it. Okay, so I need you to, let me see if I can get a better picture. Let me pause for a minute. And, yeah, let me pause. Now, ultimately, this is where I'm heading, but how did I get there? Okay, I went stat, go over to test, and then go down. With my 83, it's a 1 proportion Z interval, not a 1 proportion t-test. You need to see the number 1. That's important because it's talking about one sample. We're going to be doing 1 and 2 samples later, but now we're doing 1. Proportion tells you it's the percentage. Z, because it's a Z-score, just for the Z-star ideology, and INT, interval. I'm going to press enter. Now, if I remember correctly, my value for N, you can look, was 256. Then I dropped down. I'm sorry, that wasn't my value for N. There was 256 that 256 that said they were satisfied. So let me put this back on camera. Okay, our N is the 256 plus the 769. That's the total. Notice it did the math for you there. And now our confidence interval was 90%. Okay. Pause if you need to. Okay, we're back. I'm going to click calculate. Wow, look what happened. It tells me what the value of p hat is. It tells me what the value of the confidence interval is, and it gave me the sample size. Okay, so remember, there is no calculator talk, but all the order of operation issues you had to deal with that to make sure that I have my parentheses right and all this other stuff. Okay, you didn't have to worry about. But as I mentioned, no calculator talk. So this step 3 that I'm about to highlight right now, all of this has got to be written in your work. And yes, it's going to give you the Houdini answer of this. Notice it does not give you a Z-star though, so you're going to have to find that yourself. And remember, how did I find that Z-star for that 90% level C? Well, I need to find my cardstock. Remember, we're using our T-chart. Look at the bottom where it says confidence interval or confidence level C. Find your 90% and slide up. That's where that 1.645 came from. Okay, so go ahead and pause and finish writing down whatever you need to write down. And we're going to talk about the next set of notes in a second. Now, before we do that, I want to discuss this conclusion and just give you a basic scenario. This is not in the book or anything. But what if it was another poll, and another poll concluded that 29% of the people were satisfied? And the question is, how does that compare to the results that we have here? And the answer is that 0.29 is outside of that interval. So there is not, we don't have convincing evidence to suggest that that secondary poll would be reasonable because it is outside of that interval. And when you guys do problem number 35, there will be a scenario like that. But I want to wrap up these notes as we look here. How can we reduce sample size? Well, isn't everything based around here? And let me restate that up the right way, I'm sorry. How do I reduce the margin of error? Increase sample size. Isn't that the statistical mantra? Better samples, more samples, more samples, more samples. And when I said better samples, well, the reality behind that is not being biased. SRS means we have good samples. And how do we know we have a legitimate sample size, which takes me down to how do we determine the sample size? Here we use this equation, and this equation is not given to you on the AP test, okay? But let's look right here. We're looking at margin of error, basically comparing it to the margin of error formula. Well, so as I slide down and look at question number 44, take a moment to read that. And as you read question number 44, highlight the key information. So pause, please. Okay, we're back. Now, here is my formula. No worries because I wrote it differently. You know it's the same algebraically. So Z star is going to equal, remember these are all about hats because these are samples and P hat represents the sample. Let's take everything and plug it in what we have. We had to find the Z-score that is associated with the 99% confidence interval, the Z-star associated with that, which is 2.576. We take it, we plug in our values. You know that 44% came from there. And we solve for N. Once you solve for N, that'll give you the answer. And let me just quickly remind you algebraically of how we are going to solve for N. So you're going to take the 2.576. You're going to separate your square root. And then find out what the value for that is. There it is. Okay, so that numerator is going to be 1.2787 divided by n is going to equal m. Notice that I put equal, and the reason that I put equal is simply because I know whatever my value is going to be for n, it's got to be greater than, so I just choose not to keep it. Okay. Oh, what was my m? My m had a margin of error of 0.03, so I'm going to put a dot here. 0.03. So 0.03 n is going to equal to 1.2787. So n is going to be 1.2787 divided by 0.03. Okay, ladies and gentlemen, that's it for today, and we're ready to do our homework. I want to finish this. So this is 42.6. And then we're going to square that answer to give me the 1816. Okay, so now, and I need a square root right there, and a square root right there, and a square root right there. I lost it, but now it's okay. So now you are ready to do your homework. See ya!